Hello everybody, welcome to our NEET Physics by Your Video channel. In today's video, we are going to solve a multiple choice question from Unit 5, that is rotational motion. Okay, this is the 16th question in this chapter that we are discussing in our channel. Okay, that's all. The question is, a block of mass 10 kilogram is in contact against the inner wall of a hollow cylindrical drum of radius 1 meter. So this is the hollow cylindrical drum. It is its inner in its inner wall. A block of mass 10 kilogram is in contact. Okay, that's all. The coefficient of friction between the block and the inner wall of the cylinder. This is the inner wall and this is the block. Its coefficient of friction is 0.1. The minimum angular velocity needed for the cylinder to keep the block stationary when the cylinder is vertical and rotating about its axis. The cylinder is rotating about its axis, it passes through this. Okay, that's a rotating axis. It will be the minimum angular velocity needed will be how much? Square root of 10 radian per second, 10 by 2 pi radian per second, 10 radian per second, 10 pi radian per second. These are all the four options given to you. So in this question, it has been given that the acceleration due to gravity g is equal to 10 meter per second square. Okay, so this question has been asked in the NEET examination in the year 2019. So how to solve this question, sir? Let us look into the question. To keep the block stationary, the frictional force Ff must be balanced by the weight W. So mg is the weight which is acting downwards. Okay, n is the normal force which is acting in this direction, that is towards the center of the circle or towards the axis of the cylinder. What is the value of m, sir? M or omega square, which is your centripetal force, nothing more than that. Okay, so n is the force acting in this direction. Then what is Ff? The frictional force will be mu into m. Mu into m. Is it not? Okay, that's all. Then it must be balanced by the weight of the cylinder block so that the block remains stationary. So that the block should not come down, fell down. Okay, that's all. So W is equal to mg. So so when it is when both the forces are balanced, you can write Ff is equal to mu n, which is equal to W, which is equal to mg. That will be equation 1. So Ff is the frictional force acting in this direction. Mg is acting downwards. When these two forces are balanced, the block will become stationary. Okay, so that is the principle behind this problem. Okay, n is a normal centripetal force, m r omega square. Already I told you that. So mu is the coefficient of friction. Its value is 0.1. That has been given in the question. Then mass of the block 10 kg, radius of the cylinder 1 meter. Okay. So g, acceleration due to gravity, is equal to 10 meter per second square. That has been given in the question. R is the radius of the cylinder 1 meter. That is also given in the question. M is the mass of the block. That is 10 kg. So what is omega? Omega, when it is just balanced, when mg is equal to mu into n, when they are just balanced, the angular velocity will be minimum. That is the minimum angular velocity needed to keep the block stationary. So equation 1 can be written as, so instead of mu n, you can write mu into m r omega square. Instead of w, you can write mg. Okay? So m on both sides will get cancelled. Anyway, they have given the mass of the block and you are not going to use it in this question. So m gets cancelled on both sides, it will get cancelled. So omega squared is equal to, put mu and r to the other side. So m cancel right side. So omega squared is equal to g divided by mu r. What is the value of g? 10 meter per second square. What is the divided by? What is the value of mu? 0.1. What is the value of r? 1. So 1 into 0.1, 0.1. So 10 divided by 0.1 will give you 100. What is 100, sir? Omega squared is equal to 100. Then what is omega, sir? Square root of 100. What is square root of 100? 10. Is it not? So omega is equal to 10 radian per second. This is the minimum angular velocity needed to keep the block stationary. So option 3, is the right answer for this question. Option 3 is the right answer for this question. So far, we have discussed 16 questions in our channel in this chapter, rotational motion, unit 5 of your NEET syllabus. Okay, that's all. So you will see a multiple choice question from another chapter, maybe from gravitation, in our next video. Till then, thank you one and all. Thank you.